Hello. So this video we're going to be talking about sort of this tool that's sort of a good intuitive or intuition building way of looking at logs. So logs in general are not very intuitive things, right? So they're sort of artificially crafted as this way of inverting an exponential form. And as a result, it's really hard to build intuition. So one of the ways that we can do that is when we're sort of especially getting used to logs or sort of first working with them, is that we can look at what's called the exponential form of a log. So really what it is, the exponential form, is essentially what would happen if we sort of cleared out the log from the expression by exponentiating. And we'll see what I mean by that in just a second. But the idea here is not necessarily that this is a super useful tool algebraically. It can be, but it's more about sort of a different way of looking at what an expression is saying so that you can build an idea of what it's really asking about, okay? So the idea here is that it can be helpful to go sort of from one of these forms to the other, in particular usually going from logs to the exponential form, so that you can sort of get a good idea of what piece of information you're even trying to figure out, especially initially when you're not really comfortable with logs, okay? So normally we would have this log expression, right? So we have log base b of x equals y, right? So you'd have something like log base 3 of 27 is a number or something like this, right? And just having that sort of expression may not be terribly clear. So the exponential form is by sort of reworking what that is saying. So what's really happening here algebraically is I'm using b as a base on both sides. But the other way of thinking about this is that it's giving you a different way of looking at this relation of x and y, right? So log base b of x equals y is equivalent to saying x equals b to the y. Okay, so it's a bunch of alphabet soup. Why do I care, right? Well, let's look at an actual example. Let's say you want to know, okay, y is some log base 3 of 27. What is y, right? So like looking at this, you may not have a very good idea what y should equal. You may not even know if you could figure out what y should equal, right? Maybe you're like, do I need a calculator for this? Is this a thing I could actually sort of solve in my head somehow? Like, what am I even doing? But if I rewrite this as the exponential form, right, 27 is 3 to the y, right? I take the inside is equal to the base to the right-hand side. Well, this is actually much easier to understand. This is saying 27 is 3 to some power. But 27 is really 3 cubed, right? So that tells me that if I think of 27 as 3 cubed, then the 3 to what power? Well, that power is 3, right? So this gives you a way of answering this question, right? The log base 3 of 27, what is that? That's sort of an opaque question. It's hard to understand what that's asking if you're not used to logs yet. But by rewriting it in this exponential form, 27 is 3 to some number, that becomes much more tractable, something you can sort of wrap your head around and actually come up with an answer for. Okay? So what do? Well, we talked about the exponential form, right? So the idea is that logs themselves are very artificial. If you're just sort of getting your hands on these things and you're just starting to work with them, you may not have a good intuition as to what even an expression is asking you for. And a way to sort of work your intuition back into the game, right? A way to actually be able to think about this thing and at least understand what it's asking you for is to look at this alternative form, this exponential form of the logarithm instead, because you probably have much better intuition with exponentials than you do with logs. Okay, so that is that.